this computer. Okay, so y'all, we are going to do some simple questions. I know we did questions like this in the class, but some people were missing. All right, so we're just going to try it again. Now, folks, those who understood how to do these questions in the classroom, like when we did them last term, and you want to give them a try, go ahead. You can start right away, all right, in attempting the questions. I'm not going to fault you for trying them on your own because that's actually pretty good that you try them on your own. All right, it's a good habit to develop. So let's see what we have here on our screen or board, technically our board. So the way this little worksheet is divided up into, we have a few questions on Snell's law. We have one question on real and apparent depth, and we have a couple of questions on critical angle. Okay, so again, if you understood how to do these questions last term and you want to try them on your own, go ahead. If you want an extra question, I could quickly, very quickly jot down one on the screen. All right, so we have here Snell's law. Just to recall what Snell's law is, let's pull up this pen. I like to write it black. All right, so we have Snell's law, which states n is equal to sine of I divided by sine of r, n being your refractive index. So when you want to work this out, determine the refractive index when I is equal to 40 and r is equal to 26 degrees. So to work this out, it's just going to be n is equal to the sine of 40 divided by sine of 26. So you're all just going to plug that into your calculator. Remember, if you want a little guidance on how to use this on your calculator, you use the sine button 40. Identify where your sine button is, folks. Divided by sine button of 26, and you hit your equal sign, and you give me your answer to 2 decimal places. So you should end up getting, and if you have a long decimal, you round it up, you round it off to 2 decimal places. You don't have to round it quite up to 1 or 0 decimal places. That's unnecessary at this level. So you're going to get 1.47. You'll try to calculate it. Did you get 1.466?
Yes, miss.
Good.
Yeah, man.
All right, now 1.466, because we are using, really? Seriously? Hold on, let me get rid of that shape drawing.
Miss,
Yes.
I'm sorry for coming a few minutes late. I had a Spanish class that just finished, so that's why I left when I was late.
Oh no, and you didn't tell me that you had Spanish? But that's all right. Let's see if I get rid of that arrow. All right, so when we're doing this, we want 2 decimal places when we're doing our final answers. Get in the habit of stating your answers to 2 decimal places. So if you all had worked this on your calculator, you'd have gotten 1.4663 or something. So what you do, you get your first number, you get your first decimal, and then we look at our second decimal, and if the number before it is above 5, you round it up. All right, so that's how we go from 1 to 1.47. Let's give you all one to try on your own. All right, tell me what is your refractive index. Let's just change our color. All right, tell me what's the refractive index of a material that has I equal to 50 degrees and the refracted angle is 35 degrees. You all work out for me quickly and tell me what you get. I'll put the answer here so you can see if you got it or not. Tell me if you got the 1.34.
Yes, that's 1.24.
Beautiful. Let's see the chat. Good, great. All right, anybody has any issues? Now, I don't have the videos up, so I can't see your reactions. All right, so you're gonna need to actually use your voice and say something, and I don't want to pull down the chat because that gets in the recording. Anybody has any issues or wants me to go over it, or can we move forward? Going once. Going twice. Are we moving forward? Yes or no, folks?
Yes, miss.
Yeah, Miss.
Good.
No.
Beautiful. Question 2. This is where we're going to be using different parts of we're just going to be manipulating our equation here. So given that the refractive index of glass is 1.5, determine the angle of incidence needed to produce an angle of refraction that is 30 degrees. Now, here it really does benefit you all to get in the habit of writing down your numbers that you have. So we said that the refractive index of glass is 1.5. This mark is a bit thin. So you're going to say n is equal to 1.5. They are asking us to find the angle of incidence. So we do not know, and needed to produce an angle of refraction that is 30 degrees. So that means that R is equal to 30 degrees. This is a habit you all should develop. Learn to write down your numbers on the side or before you even start doing any calculations, so that you'll see what you have available to you, right? Rather than rereading the question. Once you read a question, you start pulling out numbers, write them down, right? Keep a note of them so it's easy for you to use them in an equation. Now, as I said, remember, if you all remember last term, I said it's easier to work with the equation and then start plugging in numbers. So what I usually do, I will manipulate our equation first and then start doing the calculation. So let's see. N, I want to find I. So let's transpose and make I the subject of the formula. So you're going to have N is equal to sine of I over sine of R. Let us cross multiply. You all should know how to cross multiply. Remember, every single number that exists has a 1 in front of it. Well, an invisible 1 in front of it, and they have an invisible 1 as a denominator. So you're going to have sine of I multiplied by 1 is equal to sine of I. And you're going to have N multiplied by sine of R. So you're just going to have N. Dot indicates multiplication. Sine of R. And if you look here, you're going to see, I know what I is. I know what R is. I can work this out. Remember, this is sine of an angle. So let's work out the sine first. So sine of I is equal to, what is N? 1.5 multiplied by the sine of 30. Now, the nice thing, you could plug this in straight into a calculator. So if you want to do this on a calculator, you're going to do 1.5 multiply button, sine of 30, and hit the equal sign. Tell me what you all get.
0.75.
0.75. Why? Why would you do that? Hold on. .75. Now this says that sine of I is 0.75. Do we want to find sine of I, or do we want to find I? Anybody?
I.
We want to find I. And the inverse of sine of I is what we call sine inverse. So you're going to press I. You're going to have I is equal to sine inverse, sine to the -1 of 0.75. Now, how do we do this on a calculator? Remember, you're going to press your second function button, your sine button again is 0.75, and you hit your equal sign and tell me what you get.
Miss, I get 48.59.
8.6.
60.
2 decimal places.
Well, 60 or something. So
48.59 degrees. You all want to try one on your own?
Yes, miss.
Okay,
Yes,
let
miss.
me just get some space to write this down. right, so let's determine your angle of incidence if n is equal to 1.5, using the same number, and r is equal to 15 degrees. Work out I for me. I'm going to work it out in the meantime and put out the answer on the board.
Zero point 0.39.
That's not the answer. You're halfway there.
Miss 22.95.
20.9. That is when you all round off your number. I wait just now. Sign of 15. Or you all rounded off and found the sign inverse of 0.39.
Yes, miss.
Okay, all right, then what you get to have is fine. I plug in the whole number into the calculator and find it. So everybody here got 22.95?
Yes, miss.
Good, beautiful. Anybody who did not get it, 22.95. So the
I just found it.
all right, so this is what you would have gotten if you rounded off your numbers. Let me pull up video, see if I can get anybody wants to give me reactions, and if you got it, yes or no, I am checking your reactions. Anybody here needs any issues? You can see, good, all right. Participants, everyone looking good, great, beautiful. All right, so let's move on to the next one. The next one is actually a little more complicated, as in one more line of working, but it's basically the same thing. All right, so determine the angle of refraction produced when light enters water at 20 degrees. The refractive index of water is 1.33. So even before we do the calculation and look at what they're asking us, we can write down our numbers. Determine the angle of refraction produced. So they are asking us for R. Light enters water at an angle of 20 degrees. So that means the angle of incidence is 20, and the refractive index of water is 1.33. So N is equal to 1.33. So we have all our numbers. Let's go and play with our formula now. So as I said, it's actually easier to, well, if you want to go and plug in the numbers right away and start manipulating, that's up to you. But I rather play with the letters first and then plug in numbers at the end. So I want to find what is R. So I have here N is equal to sine of I over the sine of R. Now what we can do our cross multiplication first, and we're going to end up getting N by sine of R is equal to sine of I. But I don't want N multiplied by sine of R. I want R on one side and everybody else on the other side of the equation. So how do I get rid of a number that is being multiplied in front of another number? Because remember this. Continue.
Miss, you have to carry across the n on the other side of the equal sign, and it will turn into divisions and a multiplication.
Well done, very good. Anytime you have a number in front of another number or another term, and you want to get rid of it and carry it across on the next side of the equation or next side of the equal sign, you divide by said number or letter. So it's going to be B is equal to C over A, because you have to remember multiplication and division are the reverse of each other. So what you're going to do, you're going to have sine of R is equal to the sine of I divided by N. So now that we have our formula, let's go and work out our R, sine of R. I is equal to 20. So you're going to have sine of 20 divided by 1.33. And when you work that out, sine of 20 divided by 1.33, will give you, you all plug it in your calculator one time, let's work together, 2.6. Everybody get 2.6?
Yes, Miss.
All right, if you're not getting it, all right, tell me, I will see when you're not getting it. And now I want to work out R. I don't want sine of R, I want to work out R. And again, R will be the inverse sine of 0.26. And when you work that out, you're gonna get second function sine 0.26, 15.07 degrees. Those who following along on your calculators, are you getting that?
Yes,
Yes,
Miss.
Miss.
Good.
Yeah, Miss.
Beautiful. Let's try one on our own now. Do I have more working space? Yes. And I'm gonna just leave this up here so you all can see the working. Let's just push this in the corner. No, I don't want that. Be scared of all of this. So let's look at our next question here. I want you to find R when n is equal to 1.4 and I is equal to 38 degrees. Following these steps here, tell me what you get for R. Let me work it out and we'll see if you all got it. Okay, so everybody did pretty okay with this question. So let's go on to the next one. This is the simplest version. We have here, how deep will water appear to be if it is 4 meters deep? Now the refractive index of water is 1.33. And our equation for real and apparent depth, because that's the topic we are looking at here, N is equal to H upon H prime, where H is our real depth, H prime is our apparent depth. Now they're asking us to find how deep the water will appear to be. So let's write down our values. We know N is 1.33. We know that H is 4 and H prime is what we do not know, right? It makes it really nice and easy just to jot down your values at the top of your working or the side of your working, because this is what you need to have when you're doing your question. So again, let's do the maths and make H prime the subject of the formula. You know, you could cross multiply. You're gonna get, let's get some more working space. you're going to get n by h prime is equal to h. And to get rid of the n, remember we divide by it. So you're going to get h prime is equal to h upon n. I know what h is. I know what n is. Let's move forward. H is 4. N is 1.33. Somebody tell me what you get.
3.01.
3.01 meters. Everybody got that?
Yes.
Yeah, miss.
Beautiful. Let me give you one on your own. Tell me, how deep will water appear to be? Changing the pen. If, so water has a refractive index of 1.33, and the water depth I am looking at is 5.4 meters. Tell me how deep the water will appear to be.
$4.06 meters.
Very good. All participants decide. So anybody who has any issues, I will see if you have any issues. If you're not getting it, tell me you're not getting it. Give me a X or a thumbs down in your reactions, and I'll see where we're going wrong. Everybody okay?
Yes, miss.
Yeah, miss. Yes, miss.
Okay, good. All right, so let's go on to critical angle. Critical angle, remember when we did, this is the last thing we did yesterday. Critical angle is, this marker is not showing up so well. The equation for critical angle is n is equal to 1 upon sine of c. All right, now I didn't give the refractive index of water because it's kind of like right here. We just did the refractive index of water. So I know that n is equal to 1.33, and I want to work out c. So again, let's play with the equation. You're going to get n by sine of c is equal to 1. And I want to get just sine of c on one side. So sine of c is equal to 1 over n. All right, so let's work this out. You're going to get 1 divided by 1.33. Somebody tell me what you get.
0.75.
0.75. And let's pull this back up again. All right, 0.75. But that is going to be sine of c. I want to work out c now. So c will be sine inverse of 0.75. Tell me what you'll get.
48.59.
48.59. Really simple. So you can work out the critical angle for any material once you know the refractive index. All right, so let's give everyone here one to try. This is the working on the side. Let me give you determine if n is equal to 1.6. Find c. That's your question to try right now. Now, for those who are watching the recording, you're in this little empty gap space, try the question on your own. All right, don't just sit down and look at the video. Here's where you're going to be trying the question. All right, so get your calculators out, give it a look. A little reminder, remember we're using the whole, or I use the entire number from the calculator. So you all should have gotten 0.625, yeah?
Yeah, miss.
All right, so you find the sine inverse of 0.625. Because such a small number, you don't need to go and round off and whatnot. Can I move on? Did we get 38 point something?
Yes, miss.
Yeah, miss.
Anybody here does not wants me to go it over? You okay? You all can give me a thumbs up if you're okay. Give me a tick if you're okay. All right. If you want me to do it over, give me a thumbs down or an X in your reactions. I'm looking at all right now. Yeah, that's a thumbs up. Don't be shy because I'm not identifying who's giving thumbs up and down. You all can't see it, I think. Aha, see, look, 1X. Let's go through it really quickly. All right, so we're doing the example, not the example, the question that I just gave on the board. Sorry. So let's just clear the screen. So I have here sine of c is equal to 1 over n. So we want to work out c, so it's going to be 1 over 1.6. And when you work that out, you're going to get 0.625. As I said, it's not a very long number, so we can use the whole number. So to get c, all you're going to do is use second function sine of 0.625. And when you work that out to 2 decimal places, you're going to get 38.68 degrees. Please try them. Try it with the calculator, see if you're getting it. Don't just watch the screen. All right, so let's move on to the last one. The last one is actually an application question. This is where you have to use the brain a little bit. This is where you're going to have to take a little extra note, right, of what we have here. So let's move on. I have here, determine if the light, now the light here is entering phase A at 50 degrees, at an angle of 50 degrees. It's entering a prism that has a refractive index of 1.5, and I want to determine whether or not the light will come out on phase B or phase A. All right, it's an application question because we don't just ask you to work out I and R. You have to see how it's going to work in your situation that you have. So let's see here. What we have to do first, we have to work out, follow this sequence here, folks. First things first, we have to work out what is the angle of refraction. This small little angle here I'm highlighted in purple. All right, so this is going to be angle of refraction. Now the angle of refraction here is going to be the same angle of incidence on the next side because it's making the same angle to your normal. All right, have you all done complementary angles as yet in maths?
No, miss.
Okay, all right, so this is something I'm telling you. The same angle that the light leaves this face A is the same angle it's going to hit face B with. So whatever angle you get for your R here, it is now going to be my I on the next side of the face. Why? What is R? R is the angle of refraction when it passes through something, right? An angle of incidence is the angle your light makes when it's now going to go through. So this is what happens. Your light enters the glass, it gets refracted a little bit, and now that same light is going to enter the glass from a next direction, and that is going to get refracted in one of two directions. So we're trying to determine where this glass or where this light is going to get refracted. All right, so first things first, we're going to work out what is R. This is an application of everything we've done for the day. So if I know N is equal to 1.5 and I know I is equal to 50, work out R for me really quickly. Let me just pause the video. All right, so let's work out R really quickly. Now, this is a little like expansion on your notes. Anytime we talk about refractive index, say I say the refractive index of glass is 1.4. That means that the refractive index of light moving from air into glass is 1.5. Now, suppose we have glass into air now. That is not going to bend the same way because let's look at it. Air is a very light material. All right, you can't get much lighter than air. And glass is what we call an optically dense material. So that is why light bends when it goes into glass. Now, the opposite is going to happen when you have glass moving into air, right? When we have light moving in glass and then it enters into air, it's going to get refracted at a different angle. So the behavior is a little different and your refractive index is going to be a different value. So generally, let's say this again. You all can write this down. Let me call it out. When light moves from air to glass, I hope you all copying it down. When light moves from air to glass, the refractive index will be 1.5. When light moves from air to glass, the refractive index will be 1.5. Full stop. However, when we reverse this motion, comma, as in moving from glass to air, the refractive index would be the inverse of the number before. The refractive index will be the inverse of the number before. Full stop. All right, so let's just write that. So when you go from air to glass, your refractive index is 1.5. But if you have the motion of glass to air, it's going to be the inverse of 1.5. And the inverse of 1.5 is just 1 divided by 1.5. And that's going to be 0.67. So when you're moving from glass to air, your refractive index will be 0.67. Everybody okay with that? Okay, good. I see one reaction. So this is where the question gets a little different. Now, when we're doing it this side of the board, let me just zoom in so you can look at the next side. Hold on it. So when you are moving from the glass, now here we are in glass. All right, we're moving from glass to air. My angle of incidence here is the angle we worked out before, which was how much? 30.71. So this means your I is 30.71. My refractive index of moving from glass, out of glass and into air, N will be 0.67. All right, everybody follow so far? Everybody, anybody, nobody? My class has gone silent. All right, I've seen ticks on yes, it's good. Now, we need to determine whether or not our light will be able to leave the glass here, right? We want to know whether or not this angle of incidence will produce either whether it will produce a refracted ray will come out of B, or whether or not it will produce a reflected ray and that will come out of C. So what do we do from here? We are going to determine what is the critical angle. I'm going to write on the steps afterwards. We have to now determine what is the critical angle of glass to air. Remember, we're moving in the opposite direction, right? So I want to determine the critical angle of glass to air, right? How do you find critical angle again? You're going to have N is equal to 1 over sine of C. So sine of C is equal to 1 over N. All right, and here you know your N is 0.67, so it's going to be 1 over 0.67, which is going to give you the 1.5. To get your sine of C, it's going to be sine inverse of 1.5, and you will actually get an error. Everybody try this for me right now. Tell me if you get an answer when you find the sine inverse of 1.5. Calculator should say math error or E. Good. Why? Because you cannot find the sine inverse sine of a number greater than 1. Sorry, there's a puppy upstairs and she's crying. All right, so this is the way maths works. You cannot find the inverse sine of a number greater than 1 or less than 1.5. So what this means, let's just take it right on this note. Not available or not applicable. So this means here, critical angle has been exceeded. So reflection, oh, my apologies, folks. I don't know why I did that. So reflection will occur. All right, so what's going to happen? If it had come out of face B, it would have been refracted. Remember, refraction is just where it stays on the same side and it just moves towards the normal. But here, since it came out the next side, because you had a light come here, hit the material and then bounce off, you are now going to have reflection occurring. So the light will end up exiting through the face of C, or the C face. All right, so folks, let's just wrap this up. We're going to stop the recording here.